Right now, as you're listening, there's this incredible hidden force working inside your chest. It's a crucial pressure that keeps your lungs from collapsing second after second. Today, we're going to dive in and figure out exactly what it is and how it works.
So let me just ask you, what's stopping your lungs, these sort of delicate balloon-like things, from just deflating completely right this moment? Well, the answer is this fascinating concept called intrapleural pressure. And you know what? It's all about a constant, gentle tug of war.
Okay, so picture this. You've got this constant battle happening inside you. On one side, you have your lungs. They're full of elastic tissue, so they naturally want to shrink down, to collapse inward. But at the very same time, your chest wall is doing the exact opposite. It wants to spring outward. These two opposing forces, that's the key to this whole thing.
So this constant pulling in opposite directions, that's what creates this really special pressure environment we're going to talk about. It's literally how our body carves out the negative space we need to breathe.
All right, so let's get a clear definition down. What exactly is intrapleural pressure? Well, it's the pressure inside this super thin, fluid-filled gap called the pleural cavity. Think of it as the no man's land, the actual battlefield where that tug-of-war is happening.
A really good way to picture this is to think about two suction cups. When you try to pull them apart, what happens? You feel that resistance, right? That's a vacuum being created between them. That is exactly what's going on here. The lungs pull in, the chest wall pulls out, and boom, you get a vacuum in that tiny space.
And here's the kicker. That vacuum effect means the pressure in there is actually lower than the air pressure all around us. In physiology, we call that a negative pressure. And it's this negative pressure, this constant sucking force, that basically glues the outside of your lungs to the inside of your chest wall, keeping them from collapsing.
But here's where it gets really cool. This pressure isn't just some static number. Oh no, it's constantly changing. It ebbs and flows with every single breath you take. So let's break down how that actually works.
Okay, so let's start with a normal breath in, just a quiet one. Your diaphragm, that big muscle, it contracts and moves down. Your chest expands. What does that do? It makes the whole chest cavity bigger, right? And that stretches out that little pleural space, making it just a bit larger.
Now, think back to our vacuum analogy. When you make that space bigger, the vacuum gets stronger, right? The pressure drops. It becomes even more negative, dipping down to around -6 millimeters of mercury. And it's that stronger negative pull that tugs the lungs open and draws fresh air right in.
All right, now what about breathing out? When it's just a quiet exhale, it's pretty much effortless. It's a passive thing. Your diaphragm just relaxes, and remember that natural tendency of the lungs? They just elastically recoil, kind of like a stretched rubber band snapping back. The whole chest cavity just settles and gets a little smaller.
So as that space shrinks a little, the pressure becomes, you guessed it, less negative. It goes back up to about -2. Now notice, it's still negative. That's super important. It's still holding the lungs open, but the pull just isn't quite as strong as it was when you breathe in.
And this really shows the whole story. You can see that jump from about -2 on the exhale to -6 on the inhale. But check this out. When you take a really deep, forceful breath, like if you're running or working out, whoa, the pressure plummets all the way down to -30. That's a huge drop, and it creates this massive vacuum to pull in as much air as possible.
Okay, but what about the opposite? Forcing air out. Think about coughing or sneezing or blowing out all the candles on a birthday cake. That's not passive at all. You're actually using your abs and other muscles to actively squeeze your chest and compress everything sharply.
And this is where we see a really interesting exception to the always negative rule. When you squeeze that hard, for just a moment, the pressure can actually become positive. It's the only time this normally happens, because that muscular force temporarily wins the tug-of-war. So this is a great little summary of the whole cycle. When you breathe in and the volume goes up, pressure gets more negative. When you breathe out and volume goes down, pressure gets less negative. Unless you force it, and then it can even go positive. It's really this beautiful, rhythmic dance between physics and biology happening thousands of times a day.
You might be thinking, okay, that's kind of neat, but why does it matter so much? Well, it matters a lot. Understanding this pressure is absolutely vital in medicine. So, what are the stakes? What happens when this perfectly balanced system breaks down?
Well, the biggest danger is something called a pneumothorax. That's the clinical term for when air gets into that sealed-off pleural space. It could be from an injury or some lung diseases, but either way, the effect is the same. The vacuum seal is broken.
And when that seal breaks, it sets off this disastrous chain reaction. Air rushes into the space, and poof, the negative pressure is gone. It's neutralized. Suddenly, that tug of war is over.
The lung's natural desire to collapse inward has no opposing force anymore. There's nothing holding it open, and so it collapses.
So you see, it all comes full circle, right back to that first idea. That negative pressure is the only thing keeping the lungs stuck to the chest wall, like a suction tub. Take away that suction, and the lung is just going to do what its elastic nature tells it to do: shrink down and collapse.
It's pretty amazing, isn't it? It just goes to show how our bodies are held in this perfect, delicate balance by all these invisible forces. And it really makes you wonder, what other hidden pressures and forces are at play right now, keeping everything inside us running just right?